Good morning, guys. Welcome to this week's home learning for maths. It's the 25th of January, and we're going to be continuing with our conversion of measures. We're going to finish it this week and end the week with our assessment. So let's get ourselves started. Now, the starters are going to be a little bit different this week. We're going back to a model we've used before of Fluent in 5. So every day there'll be 5 questions which will require some fluency style calculation. They'll require some thinking about and require you to make use your timesing, dividing, adding, subtracting skills. Might need some fractions things, might need some decimal things. So what I want you to do is pause the video now, have a look at these questions, do them in your home learning book, your workings paper, your whiteboard, whatever you're doing them on now. Have a go, then come back and I will give you the answers. Okay, let's move on to the answers to those ones. Hopefully we didn't get tricked out by this one with a box in a different place. So also with our Fluent in 5, we're thinking about which ones we can do mentally in our heads and which ones we need to do a written method for. It's trying to get us ready for that quick calculation. So the first one, 8,874 times something gave us 8,874. For the same number to be equal, we had to times it by 1. So that says m because it was mental. We could do that one in our heads probably. The next one, 1,518 divided by 6. You could have a quick think about it, see if you could do it mentally. There isn't a quick way to do it, so I would very much suggest that was a written method, probably bust up. Third one, 87.3 divided by 10. Now we've already been practicing a lot in our converting units of dividing and timesing by 10 and 100 and 1,000. So we're doing our decimal jumps method where we move the decimal point. So you could have done that one mentally and just jumped the decimal point once to the left to give you 8.73. The next one we could have done mentally, 41 add 30, just add 3 to the 4 in the tens column, giving you 71. And the last one, the numbers, if you have a look, don't really match up. You can see that you're going to have to exchange in a lot of the columns. It's tricky to do in your head, so I'd very much suggest a written method of column subtraction there to end up with 6,931. So hopefully your brains are all warmed up and we can move on. Today we're looking to convert between, oh dear, that is appalling. I've done it again. To convert between metric units of mass. Now that word mass is hopefully one we've come up against before, but we're going to explain what it is and why we're looking at it in a second. Our star words are mass, obviously, gram and kilogram. Hopefully those are ringing a bell, but you might have looked at them before. Ton and equivalent. Equivalent's still there. So when we talk about how heavy something is, so I'm using the example of a bag of sugar, we're not actually talking about its mass, the mass of that object, not its weight. Weight is the common word we use throughout, well, throughout our country, certainly throughout most of the world. We use weight to think how heavy something is, but it's actually wrong. So we're going to think about what the difference is between them. So mass is how heavy something actually is. So that when you put it in your hand, how heavy that thing is, that's its mass. Weight is actually the measure of how the gravitational pull on it. So we know gravity's pulling things down. That has a lot to do with the weight. Now, going into gravity is a bit of science. So it's all a bit scientific. So I'm going to see if I can help you in our maths to understand it a little bit better. So a good way to think about it is to imagine weighing that bag of sugar on the moon. So we're going to weigh it on some scales on the moon. On Earth, we account for gravity, so that the mass is 1 kilogram. Its weight would be the same. Its weight would be 1 Newton, we're calling it, but its weight would be the same. Its mass and weight are the same. On the moon, there's less gravity, less gravitational pull, so the mass, it would still have the same amount of stuff in it, so it still have the same mass, but its weight, if it would be different. It wouldn't weigh as much because there's not as much gravitational pull on it. It's a bit spinny to think about. So it'd have the same amount of stuff in it, same mass, but it wouldn't have the same weight because of gravity. Now, that N stands for newtons, and that's not something I'm going into in this session. You can also go into a lot of other sort of units of weight, but we're not going to go into those. Those will be when you go into big, clever secondary school sciences and maybe into university sciences. But all I want you to know is that the mass stays the same. And hello, I can't for the life of me remember what I was saying there because the door went, but I'm back now. So we were talking about not going into what Newton's are, there's lots of different measures, but actually on Earth and on the moon, the mass remains the same. Okay, but the weight is about a fifth on the moon as it would be to Earth. It all is a big roundabout way of saying we're not going to look at any of that, don't panic. It's just saying we're going to be looking at units of mass, not weight. But that's me explaining to you why. So there are 3 units we're going to be looking at today: grams, kilograms, tons. Hopefully you've heard of all of them before, and you are already thinking of some ideas of what we could weigh in. See, we say weigh, there's that word weigh. We do weigh something, but we're weighing its mass. What we can weigh in grams, what we could weigh in kilograms, and what we could weigh in tons. So thinking of the elephant, it's the most common example that I think of when I think of this unit. We'd weigh the elephant in tons. Okay, the bench, probably weighing kilograms, and a paperclip, really light, we'd probably weigh in grams. So grams is the lowest of the units, then kilograms, and then tons. So the way we're going to convert between them is grams to kilograms. So the smallest to the next largest. There are 1,000 grams in 1 kilogram. Hopefully we already knew that. If you didn't, burn that into your brain. 1,000 grams in 1 kilogram. So exactly the same as we did when we were converting meters to kilometers last week. We're going to divide by 1,000, because if we've got the big number of grams, we'll have a larger number of grams. It's going to be a smaller number of kilograms, so we're going to need to divide to get there. So let's convert 1,634 grams to kilograms. We do 1,634 divided by 1,000, because that's how many grams in a kilogram. So we do our decimal point jumpy method. We can do the bus stop and the written method, but it's so much easier to just bounce that decimal point. Now, when we're dividing, we go to the left. So we put our invisible decimal point that is always here by the 4, and we do a jump for each 0. 1, 2, 3. 1, 2, 3 jumps. So that decimal point will now be between the 1 and the 6. So we just write our number out exactly like that. So 1,634 divided by 1,000. Tell you what I'm even going to do to show you. I'm going to put grams there. Divided by the 1,000 gives us 1.634 kilograms. So grams to kilograms, divide by 1,000. To convert from kilograms to grams, funnily enough, we're going to do the opposite. So we're going to go from kilograms to the grams, so a smaller number, so 1.634 in our last example, and then we want to get back to the 1,000 number, so we're going to times by 1,000 this time. So 5.43 kilograms times 1,000. We do our jumping method, but because we're timesing, we're going to go to the right this time. So 1, 2, 3 jumps, and the decimal point over here. However, we now have a gap between the 3 and the decimal point. We cannot have that, so we need to put a place holding 0 in there. So as you can see down here, the place holding 0 goes here, which makes 5.43 kilograms times 1,000, 5,430 grams. So often, if it's to 2 decimal places, you will need to put the place holding 0 in there. If it was to 1 decimal place, you have to put 2 place holding zeros in there. It helps us out to make sure the numbers line up and make sense. But that is how we get from kilograms to grams. And then we did the opposite to get from grams to kilograms. Moving swiftly on, we use exactly the same skills to convert between kilograms and tons, because 1,000 kilograms equals 1 ton. So like meters to kilometers, kilograms to tons is 1,000. So if I had 5,867 kilograms, I would then divide that by 1,000 to get 5.867 tons. And if I had 7.23 tons, I would then times that by 1,000 to get 7,230 kilograms. Now, what I want you to do today is you're going to need to log on to Mathletics and complete the assigned tasks you've been given. The reason I'm not getting you to have a practice now is because the practice is on Mathletics, because there are 2 tasks I need you to do, and you need to attempt them both. They both focus on converting masses. One is grams to kilograms, and then the next one is tons, kilograms, grams, all 3 we've just done together. So I want you to try both of those, do your best with it, and if you struggle at all, or at the end your percentage of correct answers isn't quite as good as you'd want it to be, send me a message, or I might send you a message tomorrow or later today to say, let's talk about it. Okay, and we can have a little chat about it. So what you need to do is pause your video, off you go and do Mathletics, and then come back, because we've got some problem solving and reasoning to be going through afterwards. So pause it, off you go and do your Mathletics, and then come back. Hello, hopefully we're back. So now let's move on to our problem solving and reasoning. So you have 2 problems here. I'm going to read them both to you, and then I want you to have a pause again and have a go at them, and then we'll talk through answers. So Aileen is practicing converting different units of measure. She says, I start off with a number of grams. When converted to kilograms, my amount has 2 decimal places and is between 4 kilograms and 4.1 kilograms. Okay, so you've got a grams number, so it's going to be thousands, and you're then converting to kilograms, and it's going to be between 4 kilograms and 4.1 kilograms to 2 decimal places. Take some thinking about. What could her starting grams have been? Find 3 possibilities. Going to leave you to have a go at that one. It's a tricky one, but to initially get started with, but once you get there, it's quite simple to realize what the options could be. There are more than 3, but you just need to find 3. Now the next one, Charlotte has filled in a table after converting from grams to kilograms. So grams are here on the left. She's then converted to kilograms here. Is her table correct? Have a look at it. Maybe test grams to kilograms. See if you get the same answer. And if you don't, explain why. And if you do, explain what she's done correctly. What I want you to do is have a go at these in your home learning books, using what we've done today. Then come back and we'll talk through the answers. So pause it and have a go for me. Perfect. So let's go through the answers to these ones. Hopefully this 5 Aileen's problem you were able to get your head wrapped around. So what we need to know is we need grams, kilograms as grams. So she's going to look for her amount to be between 4,000 grams, which will be 4 kilograms converted, and 4,100 grams, which will be 4.1 kilograms converted to grams. It needs to be between those and to 2 decimal places. Okay, so the option she could have, it needs to be between here, so she could have 4,010 grams. Because if we have a decimal point at the end and we're dividing by 1,000, bounce once, twice, 3 times, it'll be 4.01. Now look, the bottom is kilograms, 4.0, so 4.01 would be just after it, and it's less than 4.10. This one, 1, 2, 3 jumps would be 4.02. Bigger than this one, smaller than this one. So you can see it followed a pattern, and you could go all the way to 4,090 grams, and then that would have gone to 4.09, and the next one would have been too big. So those are your options, and you just needed any 3 of those to get it right. If you struggled with that one, I thought it was a tricky question, so please don't be disheartened or panic. Next one. Charlotte has filled in a table after converting grams to kilograms. Is she correct? First off, no, she ain't. So let's talk about why. Now, I told you to test. So I would have chosen one of these and converted to kilograms to see what it is. So grams to kilograms, we divide by 1,000. So I took the 2,003 grams, put my imaginary decimal point, and then I do 3 jumps to the left. 1, 2, 3. 2.003. Is that what she had? No, she had 20.03. So she only did 2 jumps. I could check the rest of them, but I've already sort of proved that she's wrong, because she's only divided by 100. So I'm going to have a quick look here. Divide by 100 would be 2 jumps. She's divided by 100 there. 1, 2, and by 100 there. Now we know grams to kilograms, but 1,000 grams in a kilogram, so we have to divide by 1,000. So Charlotte is not correct because she's only divided by 100 each time. That would have been your explanation. Hopefully we're okay on that one. Now what I'd like you to do is log on to your TT Rockstars and complete at least 10-15 minutes times table fluency to keep those skills nice and fresh for when we're back. So have a go at that, and then back tomorrow for some more maths. Bye-bye now.